All right, guys, so I'm showing the results over here. Um, I'm going to go over anything under a 70%. So I'll look over a few of them. So number 2, I think it's hard to do these without actually having the diagram in front of you, which is why I suggested grabbing a marker to kind of just sketch this out. But basically, we talked yesterday about how we can turn all of these problems into a pizza. So like put a dot in the middle, draw a circle around it. And then you can trace over the letters in the order they come in. So G, B, A is that angle right there. And A, B, J is this big angle. Right? And when I see that in a picture, do you see how that's like a semicircle? It's half of it. So yesterday we talked about that semicircle, that half circle being 180, because a full circle is 360, and 180 is what we call a linear pair. So this one would be linear pair. I definitely think that's one of the harder relationships to see, which is why it helps to draw the picture. All right? So that was number 2. Just looking at the results, it looks like complementary. I think a lot of kids just mix up the definition of complementary and supplementary because they both have that ARY at the end. Linear pair is the 180. All right, let's look at, I think number 3 was the other one. Yeah, all right, so same picture. I'm going to do the same thing. I'm going to make my pizza. And then my first angle is GBM. And my second angle is MBC. I could see why some of you would choose linear pair for this one, but it's not quite a linear pair. In order to be a linear pair, I need this little slither right there too. Do you see that? It's not quite a half circle when you really look at it. Just kind of tracing over it. Like just to kind of make the image darker. It's not quite a half circle. It's just missing a little bit. So in order to be a linear pair, it would have needed that little bit more. So this was actually none of these. It's not a complementary because I don't see the box. It's not vertical because they're not across from each other, and they're definitely not equal in measure. And then it's not a linear pair because it doesn't make up that semicircle. All right? You guys actually did pretty well on these last 3, considering we didn't talk about angle measures at all yesterday. Like, we didn't put numbers to anything. I just kind of threw that out there to see if you could make the connection. We're going to talk numbers today, but I think you're going to find it to be pretty easy because a decent chunk of you got that right without me even teaching it. All right? So, in today's class, we are going to do the same angle relationships that we did yesterday, but we're going to add some algebra in it. So good news, no new vocabulary, okay? Bad news for some of you might be that now we're going to add in some math. So you might need a calculator if you don't have one out. We haven't really needed those the past 2 days. So we're going to talk about relationships between what we know: adjacent, linear pair, complementary, and vertical, and we're going to solve for missing angles. We're going to do that in our toolkit, and then we eventually will be up and moving around the room, so you'll need your workbook as well. So you'll need both of your green copies out today. We're going to start in the toolkit, though. Oh, I lied. We missed one vocabulary word yesterday. I'm adding one more. Just one. It'll be quick. Sorry. While you're getting your stuff out, I'll say that on Monday we talked about this thing called a segment bisector. Remember, it's that like knife that's coming in and it's slicing a segment in half, creating 2 different parts, 2 equal parts. An angle bisector does the same thing, but instead of slicing a segment, it slices an angle. So this definition of angle bisector is essentially this line or ray or segment that comes in and slices an angle into 2 different equal parts. Okay? So Angle bisector, a line, ray, or segment that divides an angle into two equal angles. So in this image here, image number 16, since angle AOC, think about what that angle is, AOC, is equal to angle BOC. Why do I know they're equal? They've got that tick mark, right? We talked about that tick mark. Okay, I know they're equal. The image is telling me they're equal. So since they are equal, then this ray, so it's considered a ray in the middle because O is a dot, but C has an arrow on it. So it continues forever in one direction, not both. So the ray OC, starting at O and going towards C, right, this is the ray, is an angle bisector. So because those two angles are equal, and because there's something going right down the middle of them, that something going right down the middle of them is called an angle bisector. I can only say that because I know the angles are equal. If I just had two images and I didn't know the angles were equal, then I couldn't say that. Okay, so the tick marks are key for this one. OC is the angle bisector. OC is the thing coming through the angle, creating the two equal parts. Now, I don't have any information for 17. So what I'm going to say is, if, and this is if because I don't know, if AB, which is another ray, and the reason it's a ray is because A doesn't have an arrow, but B does. So there's one direction on this straight path, right? So if ray AB is an angle bisector of angle CAD. So if this big angle here, CAD, is being cut in half by AB, then what must be true is that the two little angles should be equal, right? If it's an angle bisector, then it's going to create two equal angles. I don't know that it's an angle bisector, because like Nate said, I need the tick marks, right? I don't have them. I'm just saying if it were, then it would be creating two equal angles. So then 33 would be equal to 4x plus 1. The two inside angles would then be equal. So if it's an angle bisector, then it creates two equal angles. What are the two angles that we have? 33 and then this equation. So eventually what we do here is we could solve for x, right? We could subtract 1, 32, divide by 4, 8. So x would equal 8 in this case, if we actually did the math. Now, all of this is a big if, because I don't know if it's an angle bisector because the tick mark's not there, right? This is just a hypothetical. Everybody okay with that? Now, this image here doesn't have a tick mark, but see how it has a single red line on both of them? That's kind of equivalent to a tick mark. That's like a symbol saying this angle is equal to this one, right? Sometimes you'll see it as like a double one. I'm not saying those ones are equal. So this imagery right here is saying that those two angles are equal, okay? So here's what I know. Ray, EG, because E is a point and G is an arrow, so that's a ray, is an angle bisector. The reason I know that is because I have the image there that's telling me that it is. So an angle bisector creates two equal angles. So the two angles that I have must be equal. So I'm just going to set the two equations equal to each other. This is going to allow me to solve for x. We okay with that? All right, so if x is 12, what's the measure of angle FEG? Let's think about this. If x is 12, FEG is this 2x plus 5, right? That's the equation on that angle. So what do you think I could do to solve for the angle? Well, 12 it, right? So I could do 2 times 12 plus 5. 24 plus 5. This must be 29 degrees. And if that's 29 degrees, what's this? 29 degrees. I don't have to do the math, right? I know that they're equal. I can tell by the symbol, so 29 degrees. So today we're going to have to recognize, like, first, what is the angle relationship, right? We learned about these yesterday. Once we know what the angle relationship is, there's going to be some sort of mathematical, numerical rule that we're going to apply. And each relationship has its own rule. So we're looking at 3 different rules here. We learned 4 vocabulary words yesterday: adjacent, vertical, complementary, and linear pair. Adjacent doesn't have a rule. Things can be next to each other and have no other relationship. So you're going to learn a rule for vertical angles, complementary angles, and supplementary angles. And then you'll be able to apply them to solve for missing things. All right? So in your toolkit, the next page has this box that says angle relationships with algebra. So the first thing you have to do is draw your pizza, color in your angles, and figure out what the angle relationship is, okay? If you are looking at 2 angles, 2 slices of pizza that make up half the pie, right? You're looking at a semicircle. You're looking at a linear pair, okay? Linear pair, like a full circle is 360, a half circle is 180. So in a linear pair, pair meaning 2, you'll have 2 angles. We'll call them angle 1 and angle 2. Those 2 angles will add together to equal 180 degrees. So if angle 1 is 10 degrees, then angle 2 must be 170 degrees. Make sense? They have to add to 180. If angle 1 is 90 degrees, then angle 2 is 90 degrees, because 90 plus 90 is 180. So the idea here is I should be able to give you angles and you can plug them in, right? Obviously, it's not going to be angle 1 and 2. We know we are going to name angles with 3 letters. Okay, this is just kind of a general. We okay with that one? Okay, complementary is when you're going to see that box, right? That box is indicating that this is a 90-degree angle. So you'll take 2 angles. We'll call that angle 1 and angle 2. And those will add up to 90 degrees. So if one of my 2 angles is 30 degrees, then the other one is 60, because 30 plus 60 is 90, okay? So you'll look at the relationship. If you identify that these should make a 90-degree angle, you want to make sure they add up to 90 degrees. Finally is vertical. Vertical we talked about is those pizza slices that are across from each other, but they're the exact same size, okay? So in a vertical relationship, angle 1 is equal to angle 2. So if they are across from each other, and I know that angle 1 is 15 degrees, then angle 2 is 15 degrees too, right? These are equal relationships. So you see, we've got 3 different rules. The first step is, okay, what's the relationship? I'm not going to tell you, here's a linear pair, right? You're going to have to look at a picture, decide it's a linear pair, and then apply the rule. Okay? So let's look at some examples. And I have this kind of just copied up here in case you need it. So example 16, I like to draw my pizza You don't have to do this maybe, but I think it helps. All right, so if that's my pizza, and I'm looking at these two angles here, all right, so here's this slice. Here's this slice, right? So the first part of the problem is identifying what that relationship is. So is it complementary? No, I need to see a box. Is it vertical? No, they need to be across from each other. But it does look like together these make this half circle, right? This is a semicircle. And so I would call this relationship a linear pair. And the linear pair rule is that angle 1 plus angle 2 equals 180 degrees. So you just have to make a decision on which one you want to be angle 1 and angle 2. It doesn't really matter, right? So if I make angle 1 93 degrees plus angle 2 is 3x plus 18. So I'm just replacing the angle 1 with one of the angles and the angle 2 with an equation because that's what I know about that angle. And now this just becomes algebra 1. Combine like terms. Solve for x. All right, so what do we got here? 3x. Is it 111? Right? 111? If I combine my like terms, 93 and 18, 111, okay? So from here, I combined, so what I did here, I combined my like terms, 93 and 18, that's where this 111 is coming from. And now I'm going to subtract the 111. And divide by my 3. X equals 23. Everybody okay with that one? Now, if I wanted to find this actual angle here, I would do 3 times 23 plus 18. So that angle equals 87 degrees. So if a question might just say solve for x, and all you have to do is solve for x. But if it asks you to find the missing angle, that pink angle, I'd have to plug in what I know x is and solve for that. All right, let's look at 17. So again, I'm going to draw my pizza. And I'm going to look specifically at the two angles I'm given. So I'm given this 40-degree angle. And I'm given this 6x plus 2. Now, I know I told you that you can't assume something is a 90-degree angle without the box. However, you do have a box here. And this is on a straight line. So this would have to be a box too. Because remember a straight line, so this side would make up half the circle, right? And I know half the circle is 180, so if that's 90, then that has to be 92 because it's the half circle. So having a box on a straight line makes the other side of that straight line a box as well. So this is complementary. That's a little bit harder to see, but this is a complementary relationship. I do have the box. All right, so in a complementary relationship, angle 1 plus angle 2 equals 90 degrees. So from here, you'll decide which one you want to be angle 1 and which one you want to be angle 2. You'll combine your like terms. So that's where this 42 is coming from. if you divide by 6. You get that x equals 8. Now, there are two ways to get that pink angle, right? If you know they're complementary and you know one's 40, then what's the other one? 50. So I know that that pink angle is 50. Or you could always plug in and solve. And you're getting the 50 that way too. Either works. You can do both and just double check your work too, right? All right, so we've got linear pair, that's my half circle. I'm going to add my angles up, I'm going to set them equal to 180. We've got complementary, that's my box. I'm going to add them up, I'm going to set them equal to 90. So I'm making my pizza. All right, and I'm looking at what I've got. I've got this angle here and this angle here. I can't tell if they're a half circle because they're not adjacent, so I'm going to rule out linear pair for that one. And I don't have a box, so I'm going to rule out complementary. These are opposite of one another. And what I know about opposite angles, vertical angles, is that vertical angles are equal. So angle 1 is equal to angle 2. So I'm going to take the equation for angle 1, 2 plus 3x. And I'm going to set it equal to the equation for angle 2. You're doing one of 3 things. So if you're on a test and you have no idea what's going on, you've got a 33% chance of guessing. You're either adding them up, set them equal to 180, adding them up, set it equal to 90, or adding them or setting them equal to each other, right? Those are the only 3 things we're going to do all semester. You can guess if you need to, okay? But seeing the relationships helps. So from here, I would divide by 3. X equals 20. So if the problem says solve for x, you would do that. If the problem wants you to find the angle, you actually don't need to do any work at all, right? Because if I know that they're vertical, then I already know what that one is, right? It has to be 62. But we can always check with our math. So 2 plus 60 is going to give me that 62 degree angle. So the question's going to do one of 2 things. It's going to ask you to solve for x, or it's going to ask you to find a missing angle. Sometimes finding that missing angle, you have to solve for x anyway, and sometimes you don't. All right, what's this last relationship? We've done one of all of them. Okay, this one's complementary. Actually, let me do it over here so I have more space. All right, so this is complementary. I don't even need to draw my picture to see that because I see that box. So I know that these 2 angles add together to 90 degrees. So I've got a 2x and I've got an x plus 6. So I'm taking angle 1 and adding it to angle 2. This 2x plus x is 3x. So when you're combining those like terms, you're essentially putting a 1 in front of that x. $28. All right, so I'm going to have you kind of just take a pause and make sure you can do this. So I want you to find me Q, W, T, and X, W, T. Now that we know what X is. Right, so trace over what those angles actually are. Make sure you're putting the right angle in the right one. What's Q, W, T?
56 degrees.
I like 56. 2 times 28, 56. What's XWT?
34 degrees.
I just needed to add to 90, right? So really you only algebraically have to plug into one equation and then just subtract whatever you get from that from 90. Or you could do 28 plus 6. What do you guys think? You okay with that? All right, so a little bit of what we did yesterday combined with some algebra. So around the room there's 7 problems in blue. I have them pretty spread out. So we've got one here, one there, one behind Robbie, one behind Haley, one behind Shane. There's one by the phones, and then there's one up here. So 7 around the room. I'm going to count you off by 7s. That's just going to be where you start. You don't have to work with that person, okay? And what you'll find at these problems is 3 questions. The first one is, here are 2 angles. Tell me what their relationship is. So your answer is going to be linear pair, complementary, vertical, right? One of the words. The second question says, okay, find x then. So you're going to have to do some solving. And then the third question is going to ask you for the measure of a specific angle. So you'll have to figure out what that angle is and then plug x into that. Does that make sense? So it all kind of builds off each other. You're not going to get number 2 right if you don't have number 1 right, and so on. The answer for all of these is right under the station, so you're just going to self-check as you go. All right? So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, Bryce, 5, 6, 7. 1, 2, 3. Now 1 is back here. 1, 2, 3 is the phone. 4 is this front corner. 5 is this front corner. 6 by Sophia. 7 by Robbie. All right? So move at your own pace. Check your answers. I'm thinking 10 minutes is appropriate, but we'll readjust as needed. Tomorrow's a half day, so I'd like to get the notes out of the way so that we can do some practice on the half day. So we have half day because conferences. So we teachers have conferences.
We upload those today.
It is not. This is just conferences, so you'll have another one of those.
Those today.
Conferences are today after school and tomorrow half day. So there's 2 days of conferences. So a lot of parents that can't get in on during the day come tonight.
Are conferences for the back end?
No, your parents sign up for them. So if they want to come, they come, and if they don't want to come, they don't come. So toolkit page 6. We are just going to do the one that I have highlighted. So there's 2 definitions here. We're not going to do both. We're going to get the notes out for what's called triangle sum theorem. So here's what I need you to know about a triangle. A triangle has how many angles inside of it? 3, right? So the rule for triangles is the 3 angles inside of a triangle, no matter what the triangle looks like. Obtuse triangle, acute triangle, right triangle, doesn't matter, right? The 3 angles inside of a triangle always add up to 180 degrees. So remember how at the beginning of the day I said, you're either going to add them up, set them equal to 180, add them up, set them equal to 90, set them equal to each other. That rule still applies here. Okay? Except instead of a linear pair, it's 2 angles that add up to 180. In a triangle, it's 3 angles because there's 3 angles inside. So the rule for triangle sum theory is that angle 1 plus angle 2 plus angle 3, the 3 angles inside of a triangle, equal 180. All right, so if I'm looking at this picture and I want to solve for angle MTA, this angle right here, we'll call it X, all right? So I know that the 3 angles inside of the triangle have to add up to 180. So 82 plus 27 plus X has to add up to 180. All I'm doing in this next step is I'm combining my like terms of 82 and 27. Angle MTA, also known as X for us, is 71 degrees. The three angles inside of a triangle equal 180. Linear pair, two angles equal 180. Complementary, two angles equal 90. Vertical, two angles equal each other. Triangle, three angles equal 180. There's a lot of rules in geometry. I warned you guys at the beginning, it was a lot of vocabulary. So it's just gonna be a lot of working on remembering the rules, memorizing them, practicing them, okay? So for this next one, even though this doesn't have a number on it, it's got a box, so I know that that's 90 degrees. And we'll call that X, right? So that box signifies a 90-degree angle. So this is a triangle. The three angles inside of a triangle add up to 180. All I'm doing in this next step is combining my like terms. Right, so this part's just the algebra part, right? So it says find angle DGO. Oh, I didn't need to do any work at all, huh? DGO is what angle?
180.
90. D to G, G to O forms that 90-degree angle. I actually didn't need to find that missing angle at all. It did more work than I needed to. Do you guys understand why that's the 90-degree angle? When I trace those letters, G is the middle number, so G is the angle I'm looking for. T is the middle letter, so T is the angle I'm looking for.
Would the answer ever be 180, like, if it asks like that?
It wouldn't. If it's asking for a specific angle, it's one angle. Look for the middle one, all right? I think there might be one more triangle sum theory question. Okay, so this one's got three angles, right? All three angles are inside of the triangle, and so triangle sum theory says that I take angle 1, whichever one you want angle 1 to be, plus angle 2, whichever one you want angle 2 to be, plus angle 3, whichever one you want angle 3 to be, and set them equal to 180. The three angles inside of the triangle equals 180. From here, we're going to combine like terms. So I've got 12, so 15 in terms of my X. And then I've got 8 and 8 is 16 minus 1. So 2 15s. X equals 11. Now that's not what the question is asking. The question is asking me to find A, C, B. Really, it's asking me to find the measure of angle C. C is the middle letter there, right? So I want to find this one. So I'm going to do 8 times 11 minus 1. 88 minus 1. This answer is 87 degrees. The three angles inside of a triangle equal 180 degrees. What do you think? Lots of rules. All right. Geometry kind of moves at a faster pace than you're used to, okay? We're starting to get deeper into high school. We're going to start to move faster. Okay, so if you're struggling, remember there's always bonus blocks. You can sign up for one of them and get some extra help as needed. There's always lunch helps. You can sign up for one of those. After school helps, those types of things, all right? For tonight, not this. You're only going to get better at the vocab if you practice it. So this is another Canvas assignment. Canvas will automatically import your scores overnight. So if you have a 0 in for one of the other assignments and you go and do it tonight, overnight it will import and give you that grade, okay? So at least for Canvas assignments, you don't have to email me, you can just do them. In Math Excel, you have to email me, that doesn't import automatically. But for Canvas, if you have a 0 in there and you want to do the assignment, then do it, and it'll update overnight, okay? This is a new one, so right now you've got 3. I also started a new Math Excel. It's due on the 12th. I don't know what today's date is, but it's
Fourth.
okay. All right, so we've got about a week for that one. If you want to work on that, you can do the first 17. A lot of it is just vocabulary, so it's pretty quick paced.